Hello and welcome to my channel. Today in this tutorial, we are going to learn Wilcoxon Rank Sum Test or Mann-Whitney U-test. Sometimes it's also called unpaired non-parametric test. When we have two different data samples are coming from two different measures and we see that the data is not normally distributed, then we can ask the question, is data is normally distributed? In that case, we use Mann-Whitney U-test. In this video, how to perform Wilcoxon Rank Sum Test in R and visualize with one simple line of code and how to interpret all the results we're going to learn. Remember, Wilcox test or Mann-Whitney test is a non-parametric method appropriate for examining the median differences between two unpaired or independent samples. I have one CSV file. In this CSV file, we have two data. One is for the male and one is for the female. And it is a data of the rating of a movie from two different groups. As we can see, we have in this data 20 data points with the two variables. So let's jump in the R and we read this data first. So we comes here and we write here read.csv and give us our data is Mann-Whitney file. So we read our data file by running the code of chunk and we can see it's really nicely read the data and a data frame, and we save this data in a vector Mann-Whitney. So now we have our data in the Mann-Whitney. We check the normality of the data. Is our data is really normally distributed? So doing this, we use Shapiro-Wilk test. Here we write Shapiro test and we say Mann-Whitney for the male, and the same we gonna to repeat for the female. Shapiro.test bracket Mann-W $ female. So now we run this test and we have two results. First result for the Mann-Whitney male. Here the p-value 0.99 completely indicate that our null hypothesis is not rejected. Means data is normally distributed for the male. On the other side, we can see that here for females the p-value is 0.002, which is significantly less than the 0.05, which indicates we completely reject the null hypothesis, and here it accepts the alternate hypothesis. Means data is not normally distributed. So in this case, when we have one data is normally distributed and another is not normally distributed, so we cannot use the t-test and we directly use Mann-Whitney test. But before doing a Mann-Whitney test, we do one more time the normality test using the library dlookr. From this dlookr package, we have a very good function. It's called normality. So how we do this? We just take our data Mann-Whitney and we just write this data with our function and gives here normality and bracket. And this function from the dlookr package is very nice. Compare both the categorical vectors and gives a very nice tabulation. As we can see here, it took out both the variables male and female and it's providing the statistics in the one line, like for the males is a 0.9 and for the females is a 0.8, and is nicely giving a tabulation of p-values also. For the male 0.99 and for the female 0.002 and number of the sample. So I like this way to doing a normal test, and it also giving a same output as the Shapiro-Wilk test. So now when we have clear idea about our data that is not normally distributed, we can perform a Wilcox test or Mann-Whitney test in a conventional way using the function Wilcox test in R, and here we simply write Mann-W $ male comma female. And remember, because this is our unpaired samples, because they are coming from two different groups, so we have to write here false, and we can run this code of chunk here and it's giving us W value 255.5 and p value is 0.1368 with some warnings here. You can see like it's saying p values cannot be calculated as there is a tie between the values. So we can get rid of this warning by using the function inside this code is called exact equals to false. As you run this function, it gives us no warning and our test is a Wilcoxon Rank Sum Test, that is also called Mann-Whitney U test with continuity, correct? So like this we did this, but still we don't know how big the difference between our sample. Here comes a one very nice library. It's called library ggstatsplot, and from this library we use the function, and before this library we convert our data set into a longer format using the library reshape tool. So we run these two libraries here, and from the reshape library we use a nice function called melt, and we are using this function on our data, and you can see it's completely converted our data into a categorical vector numerical values, and we save this data as Mann-Whitney long, and we run this code of chunk here. Just don't worry about the warning. Now we have our data is called man long, and we use function gg between stats from our package ggstatsplots. And this is really nice package which gives a clear idea about any stats of Mann-Whitney. So here we use our data called man long, and we say x equals to variable, y equals to values, and type. What kind of type? This is a type of test. If you go here, we can use the type is a non-parametric because our samples are unpaired. So we comes here and we say np and run this code here. It runs the very nicely and give us a nice output in the form of a chart, and we clearly see it have a Mann-Whitney test which is showing a Mann-Whitney value or W value 250.50, same as the earlier function wilcox.test, p-value 0.14. But the nice thing is this function is giving us a rank by serial and showing this function is giving us a rank by serial and showing a correlation with a confidence interval 95 as the measure effect of size, measure of size effect, because these medians can be same also, and in the original test it is not to use the median, to use the rank. So we don't know what is the rank and how the rank sum was done. Median can be same until it shows us a significant. So median distance in this Mann-Whitney test a little bit unpractical. To get to know the effect size, we use another library. It's called size effect library. I will go effect size, and we run this code here, and from this library we can use a function to know is our data is really have some impact or there's a difference in the means, and how much it is this normal, median, or very large. So we use the function called interpret underscore r rank by serial. And what is the r value here? R value is the coefficient we use from the graph. Here is in 0.28. So we just write here 0.28 and we simply run the, and it says that the effect size is medium between our group, or median difference is very medium. So this is the way doing a Wilcox or Mann-Whitney test. As remember, Wilcox test also give the confusion when people do a Wilcox test and they don't know what kind of test they did. Is it Mann-Whitney test for the paired samples or Mann-Whitney test for the unpaired samples? So remember to use, and I personally prefer the ggstats library and its function gg between stat. It clearly gives us idea about our Mann-Whitney test, how the Mann-Whitney test was done, what is its p-value, what is the rank by serial, and what is the effect of size with the coefficient correlation. So guys, I think this was all for the Mann-Whitney U test using the different packages in R. I hope this video is useful for you. If you find this video useful, please share, like, and subscribe, and thanks for your attention.